Hi everyone, so I will be discussing Leetcode 2279 problem, maximum bag with full capacity of rocks. So in this problem we are given n bags numbered from 0 to n minus 1, and we are also given two arrays, capacity and rocks. And in the ith bag uh, it can hold up basically capacity of I rocks, and currently it contains rocks of I rocks. So, and also we are given additional rocks integer, the number of additional rocks that we can place in any of the bags, and we want to return maximum number of bags that could have full capacity after placing the additional rocks in some bags. So let's discuss this problem with an example. So we are given capacity array which is 2, 3, 4, 5, and we are given rocks array. So now currently this bag is this ith bag, which is second, if we start from zero indexing, second bag which is full. Now we have two additional rocks, and we want to add those rocks in this rocks array. So we want to add additional rocks in this rocks array to get maximum bags to the full capacity. So now currently full capacity is only 1 because this bag is full. Now if we add 1 to this first bag, we would have 2. So now this also has a capacity of full, and now additional rocks become 1. And now if we add this one rock in this, we have 3 3 here. So now this also is now full. So we have 3, we can have maximum 3 bags as full if we have additional rocks as 2. Now in the second example we are given 10 to capacity and 2 to 0 additional rocks. Now so what we can basically do is we could calculate the difference. Now difference would be 10 minus 2, which is 8, 2 minus 2, which is 0, 2 minus 0, which is 2. Now the observation here is that we want to first, now instead of 100, let's say if it would have been 5 additional rocks only. Now this bag is already full because both the difference is 0, which means that rocks and capacity both are same. Now we have only 5 rocks, and we want to either choose this or choose this to basically have maximum bags as full capacity. Now if we add 5 to this first index, we would have 7 here, and this could not be full because we want 10 rocks to get this full capacity. So what we can do is basically we can add uh, two rocks here to get full capacity for this. So we want to choose minimum difference. So here we would choose this minimum difference, and we would make this 0 and this as 2. Now we are left with only 3 we are left with only 3 uh, rocks. If we add 3 rocks in this uh, bag, we won't have this full capacity. So we would return 2 because we have 2 completely filled bags. So now I will explain what I have done in the code. So I took a priority queue, this priority queue which takes the difference. Now let's say capacity would have been uh, 3, 5, 7, 9, and rocks would have been um, 1, 3, 6, and let's say 4, and additional rocks would have been 4. Now we want maximum bags to be full. Now what I have done, basically I have calculated the differences for each case, and added them to this priority queue. So now if I loop through these capacity and rocks, and do the subtraction of the capacities of I by rocks of I, it would be then the PQ priority queue would be basically, so it's a minimum priority queue, so the peak element, it would be basically, the peak element would be the smallest element. So now here the smallest difference is 7 minus 6, which is 1 here, so 1, and 2 and 2 here, and 5 here. So this is the differences present in the priority queue. Now here I'm basically having a count variable, and I'm looping till min difference dot is empty is equals to false, and additional rocks is greater than 0. So either the min difference, which is this priority queue, becomes empty, or uh, either this is basically not empty, or this additional rocks is greater than 0. We would be having this, we would be running this file. So basically we want both these conditions to be true. If any of these conditions goes false, we would stop the loop. So now initially diff would be pole, so diff would be 1, because this is the peak element as a priority queue, and we would check if currently additional rocks is 4. So we would check if this is greater than or equal to difference, which is true. So we would subtract this to 3, because difference is 1. We want to add one element only, so additional rocks goes to 3, and we increase the counter. Now now this one is hold. Now 2 is at the top, so difference would be 2. Additional rocks is 3, so 3 is greater than 2. So we would subtract this by 2 and increment this by 1. Now this is also pulled out. Now again difference is 2. So but here additional rocks is less than difference. So I would set additional rocks to 0, and count remains the same, and simply return the count, which is 2. So this is the explanation to the solution of this problem.